Okay, today we're going to be going over molarity again. So this is day 2. If you're still a little bit confused, that's okay. We're only going to get better with practice. In order to do this worksheet, you're going to need the worksheet. You'll also need a periodic chart to find grams, and you will need a calculator. So go ahead and get that material together, and then I'm going to begin. Okay, in order to do these problems, you can use this triangle, which I've included on all the problems. Sometimes you'll use the triangle, sometimes you won't. It just helps organize your numbers. You do not have to use the triangle if you already know what you are doing. There are 3 important formulas here, depending on what you are looking for. Go ahead and follow along. You can make notes so you know what to refer back to. The capital M is for molarity. Moles is for moles. G if it's asking you to find grams. So depending on what they're asking us for, we're going to fill in the numbers we need to find the answer. Okay, so this is if it says what would the molarity or find the molarity, similar to this sample problem 1. If it says moles, similar to sample number 3, how many moles, you're going to follow this problem. So you need to find the molarity and the liters in the problem. For G for grams, it's going to be similar to sample problem number 4. Which is right down here on the bottom right hand corner. It says how many grams. Therefore, we need to use the grams formula. So these are the 3 formulas you'll be referring to. Okay? They give examples of each. If you need help, go ahead and turn to the front. I did write the first step is to convert your volume to liters. If it's given to you in milliliters, like it is right here, 100 milliliters, all you need to do is divide by 1,000 or just move this decimal 3 places to the left, whatever you're comfortable with. Let's start with number 1. At the very top on your paper, I forgot to add step 1. So if you want to write convert milliliters to liters, divide by 1,000, I'll let you do that right now. You always want to make sure your volume is in liters. Step 2, organize your data, and I put blocks there, spaces there for you. Mole, molarity, liter. I'll go ahead and work number 1 with you. I'm not even going to read the question. I'm just going to find the numbers that I need. Okay? So I'm going to put them where they belong. 0.35 moles, that would go where the mole space is. 500 milliliters, go to step 1, convert to liters. Okay, so it should be 0.500 liters. That's going to go where the capital L is. Now I'm going to figure out what they're asking me. It says determine the molarity. So I can go back to the front and use the triangle. Okay? So fill in the data for the triangle. Mole goes on top. I wrote it for you up here. See how the mole's on top there? So you can put 0.35 on the top. Liters goes in the bottom right hand corner. Liters, liters. So just put whatever number you got for liters right there. 0.500. The capital M, which stands for molarity, is in the bottom left-hand corner, and that's what we don't know. It's a mystery. That's what we're solving for. Okay, so anything top to bottom, do we multiply or divide? We divide. Okay, so we're going to do 0.35 divided by 0.500. Go ahead and type that into your calculator. 0.7. 0.7 molarity. That equals 0.7. Please box your answers or circle them if I'm unable to find your answer and it's not clear, or if I do not see any calculations or work, I am not giving you credit for it. Number 2, this one's a little bit different. I'm going to underline my numbers. This one's different. It'll be our first one when it's giving us grams. Okay, it says a 200 milliliter sample of a solution contains 4 grams of NaOH. What is the molarity? It asked us for the molarity on number 1 as well, but it didn't give us any grams. So this was the simple triangle. When it gives us grams, that's when we can turn to the front and calculate the molarity in this fashion. This is also sample problem number 2. If you want to walk through sample number 2, you find the molar mass of the compound. That's what GFM stands for. So I'm going to first write this formula right here on the back. G over GFM times L. So G over times L. And that will give me my molarity. The GFM, I have to find the mass of NaOH. How do we find the mass of a compound? When it says mass, where do we go? Periodic chart. Okay, let's find Na. That's number 11. So Na weighs 22.9. Oxygen is 15.99. Hydrogen is 1.008. If you want to put your work on a separate piece of paper, feel free to do that and just staple it, because I can already tell it's going to be a little bit messy unless you write very small. So I'm going to add these all up. So that's going to give me the GFM, the weight of NaOH. So 22.9 plus 15.99 plus 1.008. So NaOH weighs 39.8. And that's fine. You can leave it at that, or you could do 38.9. Just round up. So we have this, okay? Do we have liters? Do we have volume? It's right here. The 200 milliliters, let's change that to liters really quick. That's going to be 0.200 liters. Okay, so we have that, we have that. Do we have the grams? Yes, it's the original grams we started with, which is going to be the 4.00. I'm going to do this on a separate sheet of paper, and you can follow along. So the formula is GFM times L. And my numbers are for G, 4.0. My GFM is 39.9. And my liters is 0.200. Okay, and this is going to give me what? What are we solving for again? What's the capital M? Molarity. We'll underline it here. We are looking for molarity, which is concentration. I like to do things in steps, so of course I'm going to multiply the bottom first. I'm going to type in my calculator 39.9 times 0.200. Okay, that gave me 7.98. So now I have 4.0 over 7.98 equals M. So then in my calculator, I'm just going to type that in all together. 4.0 divided by 7.98. And that gives me 0.501. That's fine. So that is my final answer. Write it in your box. And if you do use a separate sheet of paper so I can see your calculations, make sure you staple it to your assignment. Okay, I will do one more with you, and then you have the rest of the period to complete 10. I am picking it up at the end of the period, so if you need help, we can rewatch the video, or come sit at the table to the side and I can help you. So how many grams of KNO3 are needed to prepare 25 milliliters of 2 molar solution? This is just like the previous one we did. We are looking for, actually this one we're looking for grams. How many grams? Let's go to the front. Which one is going to give us grams? This is the formula we need for grams. G equals capital M times GFM times L. Okay. G equals capital M times GFM times L. I'm going to give you a minute to see if you can fill that out yourself. All you're doing is looking in the problem to see if you have these numbers. Okay, so look for capital M. GFM is the weight of this, so you need to go where? How do we find the molar mass? Periodic table and liters. So go ahead and try working that out. I'll give you a moment. In order to find the GFM of KNO3, you had to get the mass of the K, which is 39.9, N is 14, O, it's O3, so how many oxygens do we have to account for? 3 oxygens. So it's 15.99 times 3, which gave me 47.9. I add all 3 of these to get the total mass of KNO3. So I'm going to type that into my calculator. 101.8. Now do I have all the components of the formula? I have my capital M. It's right there. It gave it to me in the problem. It was 2.0. Okay. It gave me milliliters, so I converted it to liters. I wrote it right there. I had to calculate on my own the GFM, which I did there. I'm going to go to my separate sheet of paper so it's more clear. This is number 3 I'm working out. So my capital M is what? What is the molarity? 2.0. What is my GFM? And what is my L? as easy as that. All I have to do is type that into the calculator to get my answer. $5.09 grams. I do need to see your work when you're calculating these. I'll leave this up here for a moment. Again, please finish this worksheet. By the time the period is over, I will be collecting it for a grade. If you need any help, please come see me.